You're listening to Electrician Live with your host, Paul Abernathy. Well, hey everybody, welcome to another episode of Electrician Live. My name is Paul Abernathy, your host, as always, and I want to welcome you to the actual stream. So we do this every Saturday night at 8 p.m. Central Standard Time. The topics can vary. So what I want to tell you is what we got coming up next week. I'm going to talk about it early. There's a lot of work that's going to take place during the week because I have a special guest who's actually coming to the studio, as well as we have some special guests that are going to present for us two different things next week. So mark your calendar because it ought to be a great show. It's going to have our guests are going to be from Siemens. So if you're not familiar with Siemens products, they're going to talk about their revolutionary snap-on type of neutral. And they're going to talk about, it's called a plug-on neutral. And they're going to talk about their load centers, some things that have changed that are pretty much revolutionizing the industry. They're also going to talk about the construction of some of their load centers and what is changing. And again, about some things aren't going away, but they're going to be adding some things. And we also have a special guest with them as well that's going to talk about SPDs, surge protective devices. And of course, then in the studio, we're going to have Vince Delacroce with us. And Vince is going to be with me, and we're going to go over some of the things that have significantly changed when it comes to over voltage and dealing with Article 242. So we're going to round that episode up next week with that. So it's going to be an all Siemens episode. And we're going to be able to look at it and, of course, dig deeper into these different types of products again. So they have kind of paved the way for plug-on design. So it's all about making more space in a panel, and it should be a great show. So I encourage you to bookmark it or subscribe or whatever and join us next week for that great episode with our guests. Okay, so today's episode, we are going to talk a little bit about service bonding. Now, I've covered this before in other episodes, but I had a request from somebody that said, Paul, will you dig into the grounding and bonding aspect of your grounding and bonding course that you offer and just look at service bonding? So I figured I would do that, and we would look at it in the National Electrical Code. And of course, we're going to talk about 2020 edition tonight, but again, nothing was significant from the 2017 to the 2020 that makes any impact on what we're going to talk about tonight. It's just for convenience and to be fresh and offer something that's a little bit of a change. So we're going to be talking about that tonight. So if you're listening to our podcast, we encourage you to come and join us every Saturday night at 8 p.m. Central Standard Time over here in the live stream, which is over at our YouTube channel, which is youtube.com/Master the NEC. But guess what? You can also watch it on our website, electricianlive.com as well. Now, the only benefit of being over here on the actual YouTube stream is that you can interact with us and chime in if you want. I'll read some comments, things like that. So you can watch everything on Electrician Live, just can't comment. Okay, so if you want to comment, jump on over to our YouTube channel. All right, so we're going to kind of get started so that we can fall within our time frame. Hopefully everything goes okay, and all of the switching and everything. I like to think now, we've been doing these Electrician Lives now since January. So we're right here in June, so I guess it's our 6-month anniversary when it comes to Electrician Live. I like to say that I bought in COVID-19, and I'm still with it. Okay, so hopefully we will outlast it. And as we started this in January, and I guess that started somewhere around there. So hopefully you're all staying safe and getting back to work, hopefully soon. Many places are starting to go back to work. And I'm still working from home. It's been about 2 months now, I am itching to get back to my office, okay? But we're going to keep on plugging forward. All right, so let's go on and get started tonight. And of course, we'll look at the code book. For those that are over in the video stream, they'll look at the code book and I'll share a presentation. Now, this presentation is it's kind of a treat because it's out of our grounding and bonding series. And if you want more information on getting our grounding and bonding course, then all you have to go is to masterthenec.com or electricalcodeacademy.com. Under the courses, you'll see that we have the 2020 edition of our grounding and bonding course if you really want to get your head wrapped around all things grounding and bonding. I'll also remind you that we have a webinar that's going to take place on June 20th that really digs deep into the grounding electrode systems and all of the different types of electrodes and how they interact. And we're going to talk about the things where you used to hear this term daisy chaining and it's all gone now. We're going to talk all about that. So if you ever wanted to know all the aspects of establishing a good grounding electrode system and the electrodes, then you want to make sure you visit that webinar. It's also over on the website down at the bottom. You can join us at that webinar. Again, it's June 20th. Okay, so check us out for that. All right, so let's go on and get over into our presentation. So we're going to actually be in bonding today. So bonding being part 5 of Article 250. And I should say that while it's only a couple pages, the importance of part 5 is huge because it talks about service bonding. It talks about bonding of other raceways that are likely, or other piping systems that are likely to be energized. It also engulfs us into 250.102, which talks about sizing the grounding conductor and the supply side bonding jumpers. And there's a lot that's packed into just a couple pages. And again, if you think of it that way, it's much easier to tackle when you think of, look, what are we trying to accomplish here? We're trying to do something that's in bonding. Now, always remember, service bonding is going to be at a higher level, and it's going to have some things that talks about things like assured bonding or extra practices that you might have to do, okay, than you would maybe on the load side of an overcurrent device. Still got to do the bonding, but there are just things you have to do a little differently when it comes to services. And as an electrical inspector for years and head engineer at the city of Richmond and in code supervisor for the city of Alexandria, Virginia, right outside of DC, I would see some of the worst cases of service bonding. And so when I get questions about service bonding, it really wants me to dig deep and have to answer these questions for people because it's not as complicated as it might seem if you remember all the principles. Okay, so we're going to kind of look at it. And where I get in the way or where my body gets in the way, I will shut me off, hopefully to not cause any confusion for those that are in the live stream. For those that are over in the podcast, I'm going to read the material to you and try to visually explain it the best I can. So in our presentation, our grounding and bonding presentation, when you go through this unit, which talks about bonding, and it's going to go way deeper than we're going to go to tonight because it goes into bonding for feeders and branch circuits and all those type of things, you're going to get a real good understanding. The same way you're going to get it in our webinar when it comes to grounding electrode systems, because we're going to use our program in order to be able to offer this to you. And this is all part of our grounding and bonding series that we have on our website. Now, after studying this unit, the reader will be able to summarize the general requirements for bonding. You'll be able to explain bonding requirements for services. You'll be able to summarize the bonding requirements for other enclosures other than service. That's in the general presentation. We're only going to talk services today. But in our program, you'd be able to explain bonding requirements for equipment if the voltage at the equipment is over 250 volts, because you have special requirements for that. Our program would cover that as well. And of course, you'd be able to summarize the requirements for bonding loosely joined metal raceways. Okay, all of that would be something covered in our program. And of course, we also would go into hazardous location bonding and sizing and attachment of equipment bonding jumpers. All that type of stuff would be in our general program. Now, remember tonight, we're only going to focus on services. But as you can see, part 5 gets pretty deep. There's a lot of information that we would cover. Okay, so first things first, when we talk principles of bonding, there's no way that we can have a firm grip or understanding of bonding unless we understand the difference between bonding and grounding. So if you're watching in the video stream, what you're seeing is two metal boxes that are connected together by a metal nipple. These two boxes are metal, conductive, and they are bonded together through the metal nipple, okay, which is a raceway. And so again, it extends the metal from one box to the other. That is considered bonding. Now, when we run equipment grounding conductors, and everybody wants to call those equipment bonding conductors rather than what they're called, equipment grounding conductors, because they think that bonding is the major role that it plays. Okay, bonding is a major role, but it also establishes a reference to ground. Everything in that equipment grounding conductor comes all the way back to the main service panel. And so either way you call it, it's still doing a function. It's going to provide grounding and it's going to provide bonding. Well, when you're dealing in part 1, 2, 3, and 4 of Article 250, you're dealing in grounding. We're in part 5. We're trying to focus more and more on the bonding component. So what is bonding? Bonding is required where necessary to ensure electrical continuity and must have the capacity to conduct safely any fault current likely to be imposed on it. That's why it's so important that we remember about the connections. Okay, it's not just something that we take for granted when we have MC cable and we go into a listed fitting and we make a connection to a metal box. Or we run EMT tubing and we make it into a connector and we make it up to a box. It's how we make those connections are so vitally important. Now 250.8 give us all these different connection requirements and different ways to do it, but we have to do it and we have to understand how to do it. Okay, that's the critical component when it comes to bonding. So we're going to talk about it again. We're going to focus on service bonding today, but I want you to understand that by bonding these metal parts together, tying them all together, doing it properly, extends the ground connection to earth because it can be utilized as an equipment grounding conductor. You don't necessarily have to have a wire type equipment grounding conductor in your installation if your raceways are listed in 250.118, if your boxes are metal, all of those things are also an equipment grounding conductor. But the act of bonding all of these together is bonded. They are bonded at that point, okay? So when we look at it, some of the terms, the term bonded or bonding is defined in Article 100 as a connection to establish electrical continuity and conductivity. I mean, that's the purpose while we're bonding all these metal parts together, okay? When you get up into 680 and we're talking about pulls and you've got equipotential bonding grid, you're tying everything together in order to reduce voltage gradients, okay? But when it comes to bonding at services and bonding metal boxes and everything together, you're literally doing this to provide electrical continuity and conductivity. In case it gets energized, it allows for an overcurrent protector device to function. You also on the service are tying all metal parts together so that you don't create differences of potential. And if you have a difference of potential and you come between that, then that's how you're going to have current generated through you and you're going to feel that difference of potential. So bonding everything together brings everything to the same potential. You're never going to remove it. If it gets energized, it gets energized. But if you don't bond it all, then you're not going to clear a device, okay? So again, all these things taken into consideration. Now, when it comes to services, we're on the supply side of the service disconnection means. So the reality there is you don't have any overcurrent device to trip. So why are we doing it? We're doing it because one, we're hoping that they have some overcurrent device on the primary side of the transformer that will blow in an incident. And we're tying all metal parts together so if we come in contact with them, that there is no difference of potential, or at least as low as possible, okay? So the requirements for bonding is performed in many ways. Equipment bonding jumpers, supply side bonding jumpers, system bonding jumpers. We do a lot of bonding, okay? And all of that's done, again, is to establish electrical continuity and conductivity for all of those connections. Okay. Now, requirements are included in most parts of Article 250 that we are talking about bonding, but you'll start to see that when we're talking about Part 5 today, it is very much heavily dealing with bonding. Actually, that's the title of that part, and so that's what we're going to focus on. And of course, we're going to look at the code where necessary in order to bring all these references together. So 250.92a in the National Electrical Code. Actually, before we do that, we do need to go to the browser and we will look and see what the code says. So the code says that 250.90, which is general, it says bonding shall be provided where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed. So we're tying all these parts together. 250.92 is specific to services. Okay, it says 250.92a, bonding of equipment for services. All right, so that's what took us into our presentation, so where we're at. So I just wanted to show you in the code where we're at. It says normally non-current carrying metal parts of the following equipment must be bonded together. Okay, so if you're over in the podcast, we're talking about what electrical equipment on this dealing with the service side, which is the supply side, up to and including the service equipment, what do we have to bond in order to meet this rule in 250.92a for bonding of the service? All right, so number one, it says all service raceways, cable trays, cable buses, cable bus framework, auxiliary gutters, or service cable armor or sheath, except as permitted in 250.80. Now, 250.80 is talking about, hey, if I've got, let's say, the raceway is underground and it's PVC, and then I have an elbow and it's below 18 inches, yeah, I'm not going to go connect to that. There's no need to go and make a connection to that elbow, okay? It might be there for many reasons. It could be there because of the pull, and if you pull the size of the conductors, you pulled it, it could cause friction and cause problems on the inner radius of the actual elbow, so they changed it to a metal elbow. Well, if it's below 18 inches, no need to bond to it. It's considered out of touch for anybody to come in contact with it, okay? All right, and I'm not exactly sure how you would do it anyway. I guess somebody will come up with some way, but not necessarily to do that. Number two, it says all enclosures that contain service conductors, including meter fittings, boxes, or the like, interposed on the service raceway. So interposed means, you know how you go from a weatherhead overhead and you go to a weatherhead and it comes down to the raceway and then it comes to a meter. And then it goes out of the meter straight down into the service disconnection meter, or the 2020 code, it might go into what's called an emergency disconnect. But it also is considered maybe the main service disconnect as well, because it could be. So anyway, putting the meter in that path of those service conductors is considered interposed. Okay, you put it in there. Okay, so you actually took a raceway and you put something in the middle of it. You're interposing it into the middle of that run. Okay, so that's what you have when you have a meter, when it's interposed between the service weatherhead, which is probably the point of attachment to the structure, down through the meter and into the service equipment. That meter is interposed. Okay, you could have other boxes. You could have other gutters that are interposed in this system as well. Okay, so all of those things interposed into it, and they're all going to have to be being bonded. Okay, all those metal parts are non-current carrying metal parts. Okay, they're either enclosing or encapsulating or enclosing, like in a box or in a gutter or in a raceway, service conductors. Okay. Now, if you look at this graphic, this is kind of a really good graphic. This is a graphic that's out of our series. And again, I encourage you to check out our series. It is the 2020 edition of the Grounding and Bonding, which literally have hundreds and hundreds and hundreds of graphics in them and quizzes and things like that to help you make sure that you really understand it. Here we see the utility, and we see it coming down to the point of attachment. You have a weatherhead, it's coming down. That meter enclosure, for example, is interposed in that system. Okay, and it comes down, and then of course here you have a metal wireway. Now this is not an auxiliary gutter. Okay, this is a metal wireway because an auxiliary gutter tends to be adding additional wiring space to other pieces of equipment. Some might argue this is auxiliary gutter, but the intent of the drawing is not. It's to be a wireway. But the point is, all of this metal parts is on the supply side of the service disconnect. And we have two service disconnects here. Of course, we can have a grouping of up to how many? up to 6 of them in one location, correct? Individually. Remember, there was a code change that says I can't put them all in one enclosure anymore. Has to be individually, but there's some other allowances as well. Make sure you go check out our video that we did on the changes to the 2020 NEC when it comes to this application as well. Okay, so in this case right here, you can see in the graphic, all of these metal parts that are shown. Now, if you're on the podcast, what you're seeing is metal raceways, metal meter enclosure, a wireway, and then the metal cabinets that house the panel board for this service equipment. All of this metal has to be bonded, okay? And so we're going to bond it, and that is kind of what we're talking about today. All these things have to be bonded together. Now, let's look at methods of bonding at service. So we're at 250.92b. Now, again, we'll go back to the NEC so we can see where we're at in the NEC so that we have a kind of an understanding of where we're at. And here at the NEC, you see that we have 250.92b, and it says methods of bonding at the service. So what does the code say? We'll look at this and we'll go back. But the code says bonding jumpers meeting the requirements of this article shall be used around impaired connections, such as reducing washers or oversized concentric or eccentric knockouts. Okay, so we already know something. When we're dealing with services, we could run into concentric, eccentric, oversized, where we have to use washers, reducing washers to bring it down for whatever connector or fitting we're using. Okay, when we do this, or we have any type of impairment on that connection, then we have to use a bonding jumper. You have to, okay, when you have an impairment. Now, some people ask, they say, well, what happens if I have no impairment and I punch the hole? If you punch the hole, then you don't have an impairment. And if it's the proper sized punch hole, then you have some other allowances that we'll look at in a second. Okay, but we're talking about impairments of some type. Now, it's real common for me to see enclosures where the actual concentric eccentrics they were knocking them out and then they loosened the other ones and they're all bent up. Again, that is an impairment and you're going to need a bonding jumper. Okay, it says it right in the beginning of the code. It goes on to say that standard lock nuts or bushings, and that would be standard bushings, not bonding bushings, standard lock nuts or bushings shall not be the only means for bonding requirements by this section, but shall be permitted to be installed to make a mechanical connection of the raceways. What is that telling us? That says that, look, you can still use lock nuts, but lock nuts can't be the only method to make that bond. If you need it to hold the raceway, or if you need it to hold the fitting, that's fine. That's a mechanical. It is not there to make that bonding. Most certainly not when it comes to the issue when you're dealing with bonding jumpers. Now, something else to remember, in no case can you use a standard lock nut to do any bonding when it comes to services. Okay? There are going to be some other allowances, but not standard lock nuts, okay? All right, so now that we got that straight, let's get back to the presentation, and we'll kind of look at each one of these things and kind of wrap it up on this part of it. All right, so methods. Bonding jumpers meeting the requirements of the article are required to be used, again, around impairments. We talked about that. Standard lock nuts or bushings may not be the only means, but they can be there for mechanical purposes, not for the assured, I like to say that word, assured or the known practice of bonding that's required. If we have any of those type of impairments, bonding jumpers are going to have to be installed. Okay. Now, when you look at it here, you look at this example. Now, people that are over in the podcast, what we're showing here is a bonding bushing with a lug, and it's connected onto a reducing washer, okay? And that's what we're dealing with. Now, for me, I'm going to remove me because I block most of the information that's on this screen for those that are over watching in the video stream. But it says here, now what you see on the screen is examples of concentric or eccentrics. Now, these, I believe, are concentrics, knockouts, okay? So any of these would require the use of a bonding jumper. Even if there wasn't a reducing washer there, it would still require it to have a bonding jumper because it is concentric or eccentric. It's considered impaired. Now, what the code says here, it says at the service equipment when using metal conduit or EMT, remembering that EMT is a tubing, not a conduit. I hear that a lot. It says bond around all impaired connections such as reducing washers, oversized, concentric, or eccentric knockouts like you see right here in the example here. And I believe this is probably an EMT coming in from the bottom. Okay. Now, you notice it says figure. It says at the service equipment when using metal conduit or EMT. Actually, it's the same thing I just read. Also, one thing to remember is where paint has not been removed between the fitting and the enclosure, okay, you would need to use a bonding jumper. Obviously, you're going to make sure that you make that connection as well. But this is driven towards impairment is the key that I want to hammer home here. It's all about an impairment. Now, bonding of these enclosures is to be ensured by one of the following. Okay? All right. So let's kind of look at this. We'll kind of go back to the code for those that are following over in the stream. We kind of go back and look at the code. You'll notice it says in the code under 250.92b, it says, again, electrical continuity at service equipment, service raceways, and service conductor enclosures shall be ensured by one of the following methods. Number one, bonding equipment to the grounded service conductor in a manner provided in 250.8. Now, 250.8 gives us different allowances for lugs and different methods to make these connections. Okay, so 250.8, and of course, those that are over in the stream that are actually over watching this on the YouTube channel, they'll notice that I will click 250.8 and you'll see that it'll take me all the way back to 250.8, which talks about the permitted methods. Again, listed pressure connectors, terminal bars, again, pressure connectors listed for grounding and bonding equipment, okay, things like that. All of those items, there's 8 options here. Those are permitted methods for making the connections for grounding and bonding of equipment. Okay, that's the reference that it's making to it. Okay, so now I go back to where I was before I click the button, which jumped me all the way down to the bottom of the page for those that are watching over on the stream. Okay, so now we'll go back to the presentation for those that are watching again, and I will try to explain this to everybody that's on the podcast. Number one, we talked about it. We're going to use one of the options that are in 250.8, and again, your lugs in your panel for the grounding bar, that's an example of a 250.8 to make that connection, okay? All right, let's see here. Let's go on and go, trying to figure out where I'm at here on my screen. Okay, so one of the things that gets done very often, which is totally okay with the code, is using the neutral to bond on the supply side, okay? So again, 250.142 gives us this permission. But I like to show a graphic that kind of really hammers it home. When you think about using that neutral, here's what you're doing. If those that are watching the stream, what we have, and those are on the podcast, we have a CT cabinet that has an auxiliary gutter that's added to it, which is adding additional space. And then, of course, you have 2 nipples that are coming down and hitting 2 separate service enclosures. Okay? All of the metal parts on the supply side are all to be bonded together. Okay. Now, the code allows me to bond them as well to the neutral conductor. Now, of course, in all these service equipments we have here, we're going to have main bonding jumpers, and that's going to connect our grounded conductor to our equipment grounded conductors to the enclosure and ultimately to the grounding electrode conductor as well. But also you have various types of supply side bonding jumpers that are going to connect each one of these components together, whether it's the gutter to the actual CT cabinet enclosure. And of course, in the CT cabinet enclosure, we have a supply side bonding jumper connection there. Okay, that would not be the main bonding jumper. That's over in our service equipment. That's a CT cabinet. But the point is, you notice that the bonding of the raceways, the bonding of the auxiliary gutter, all of that is to the actual cabinet. and the grounded conductor is connected directly to the cabinet. So they're all tied together. Now you ask yourself, why can I do that on the supply side, but I can't do that on the load side? Well, rather than blow your mind, it's okay on the supply side because that is where we're trying to get reference of potential between all metal parts. We don't have an overcurrent device that we can control, but the code tells us we have to do this. So we could really get into the deep whys, but we really need to know that we just have to do this. And so this is an example of tying it all together. Okay. Now, when we get into our course on the grounding and bonding course, we dig deeper into the why. But I don't want to take up all our time because we have a lot of stuff to cover tonight. Just know that you have to do it and tie it. But you can use the neutral to do this. Okay. And that is very common to do. And that gives us the allowance to do this. But you'll notice that all of the connections in this picture are utilizing some type of lug that would be listed in 250.8 to make this connection. And that's really the point we wanted to hammer home with this one. Okay. The next one is looking at is what about remote meters? Now, remote metering is where you actually have a meter set up and it literally is remote of the service equipment. It's upstream. The meter is not right there interposed at the normal weatherhead coming down and then straight into a service disconnect application. It's remote. So you might have an overhead that comes down, hits a meter, then goes back out and goes up and hits on over to the house. It's considered remote. Okay. Now, that meter base in that remote, it's remote, is going to have to be bonded to the neutral. Now, in most cases, the meters that we're dealing with, mostly in residential, are going to have it set up so the grounded neutral conductor does make contact with the case. But you do have meters you have to be careful that are called tenant side meters that would not. Okay, so you have to be very careful of that application. But verify that the neutral is bonded to the enclosure. Always make sure that. And I tell people, as I always tell electricians, don't be afraid while you're doing this setup is to take the continuity tester on your meter and check from the neutral over to the case once it's terminated to make sure that it rings out. We want to make sure that that connection is there. Okay. We don't want to have any difference of potential. We want to give anything that might energize those metal parts the ability to get back to that neutral, back to its source. And if there is some type of overcurrent protection on the supply side by the utility, that it will hopefully clear. Okay. We don't know what they do, but we're hoping that it's going to give us something. Okay. Now, connection of the grounding electrode may be required by the servicing electrical utility. This is something I want to bring up. There are many people that say you cannot put the grounding electrode conductor inside of a meter enclosure. Now, I will remind you that you want to put the grounding electrode conductor at the service disconnection means, where you're going to have the grounded conductor and the equipment grounded conductors all come together inside of the service equipment. You are permitted to also have a connection to earth here at the remote meter. And in fact, some utilities may require it. But let me address putting a grounding electrode conductor, whether it's an auxiliary electrode or it's the grounding electrode conductor that's required at the service, putting it inside of the meter. Many of them don't like it. Many jurisdictions don't like it. They say that it has to be readily accessible. I disagree. It's readily accessible to those that need to get there to it. Once it's inside the meter, if there's a tag on it, usually if you terminate it right, you torque it right, you do it, why do you need to get to it? The code actually says that it can be installed anywhere up to the service point or the point of attachment. It can be anywhere on the supply side, including within the service equipment, all the way up to, again, like this case, up to the weatherhead. So it could be anywhere in there you could actually make that connection. But we typically do that in service equipment. But nothing that says it can't be in the meter. But many jurisdictions don't like it. So again, rather than fight, sometimes they like to fight. Maybe you just don't do it. But some of them might, on a remote meter case, might want you, like shown here in the graphic, they might want you to put what's called an auxiliary electrode provided. Remember, that's an auxiliary. That is not your grounding electrode for your structure. Okay? It's not. It's an auxiliary electrode. Doesn't have to meet the same rules as we do for a grounding electrode conductor that's at the structure. And again, we're going to cover all that in our June 20th webinar. So hopefully you sign up for that and enjoy that, because we're going to go over all these little nuances that have to do with things like this. All right, so another remote metering situation. Here's a CT cabinet with an offset meter. Okay, prime example here. You have a CT set up. You have multiple sets coming in, and all these metal parts are bonded together, and they're bonded to the neutral. Okay, so bonding current transformers type enclosures that are installed remote from and on the supply side of service equipment, all permitted in 250.142, all a common practice that we follow in 250.92b1 as well. It bonds all these metal parts together. Okay, very common application to utilize. All right, so the next one we look at here is 250.92b, and that is number 2. Now, let's go back to the code so we can go back to look at what the code says as we change back and forth into the code. All right, so number 2, we covered the first one. Number 2 says connections using threaded couplings or listed threaded hubs on enclosures if made up wrench tight. So that's the one we're dealing with in that scenario. Okay, so let's kind of go back and look at what we're dealing with here. So as you see, those that are watching on the video, those are over in the podcast, I will explain. We have a wireway that comes up from a lateral, and you have multiple services here, and they're interconnected with the equipment using nipples or threaded couplings or hubs. So one example, we see a meter on the left where a meter directly connects to an exterior panel, and it's going through a 4-screw mounted hub that sits on the top of this NEMA 3R enclosure, and then the meter sits directly on top of it. Okay, so that's considered bonding the actual enclosure to the nipple, to the meter. All of that's connected together, and that's okay. That's acceptable to use a threaded hub. Over on the right side, you see threaded conduit couplings. Perfectly fine. Now, another thing that people ask me, can I use a weatherproof hub like a Myers hub? Well, yes, if it is listed for grounding and bonding use. Just verify that the one you're getting is listed for grounding and bonding, then at services, because again, it has to be for grounding and bonding with services applications. If it is, then it's perfectly okay to utilize as well. Just make sure that it's listed for bonding at services, not just bonding in general. So this is an example of what they look like. For those that are over in the podcast, I'm showing a picture of some hubs, and these are courtesy of Thomas & Betts, and these are some examples of some hubs, and you'll see the one on the left, which has the screw on it. That one is definitely rated for service bonding. So these are weatherproof hubs, suitable for installation at service equipment, and they have to be listed in compliance with UL 467 in order to meet this allowance to be used as service bonding. Okay. Again, all you have to do, if there's ever a question, I usually have people that say this to me. They say, "Well, how do I know?" Look, and I realize that I'm blocking this, folks. All you have to do is ask the manufacturer. The manufacturers will give you any information. Now, if you do something wrong and it's rejected, and you go, "Well, why did I fail?" And they say, "You didn't show me the material." Remember, all you had to do was reach out to the manufacturer and say, "Is your piece of equipment, is this fitting listed for bonding at services?" I can guarantee you, for example, I know the people at Thomas & Betts, which is now ABB. They will give you any information that you need. Any information that you need. Okay? No reason not to ask. Now, the third item we saw in 250.92b was threadless couplings and connectors were made up tight for metal raceways and metal clad cables. Okay, so the picture that we show here are some threadless couplings, referred to in many cases compression couplings. Okay, these get made up tight and they are fine. That's considering bonding one raceway, in this case, a raceway to the elbow, to the other raceway, those couplings are continuing that bonding from a horizontal to an elbow to a vertical raceway. Okay, that is perfectly fine. As long as they're made up tight, not a problem. They're considered adequate in order to maintain that service bonding. Okay, again, what do we got to have in these raceways? Service conductors. That's what we're dealing with, service conductor applications and service bonding. And then item number 4 says other listed types such as bonding type lock nuts, bushings, or bushings with bonding jumpers. Okay. Now, when we hear the word bushings, a lot of people will get this confused. So you've got a couple different types. You have a bonding type bushing, which has the built-in lug, built-in ability to connect and connect down into the raceway or the fitting. Okay. You also have what's called bonding type wedges. And the bonding type wedges are typically designed to go underneath a actual metal bushing, and they work in conjunction. Okay, so the bonding wedge, kind of we call an oops wedge, slides in around the conductors where you forgot to put one on. Okay, so that's typically what you would do with that. Now, some of the manufacturers today have these neat bushings that open up like Pac-Man, if you will. The easiest way for me to describe it is they literally will open up and look like jaws. And they really do make for a lot of installations where you might goof up. So we're going to go back to the code real quick and look at the code because we're looking at item 4. Now notice it says other listed devices such as bonding type lock nuts, bushings, and bushings with bonding jumpers. Remember something real important, that this applications where you don't need a bonding jumper is going to be where you don't have an impairment. But you're still going to need something like a bonding lock nut, which is the kind that we show with the screw that drives down into the fitting. Okay, those are going to be still required for you to be able to utilize. Okay, but if you have an impairment of any type, you cannot get away from a bonding jumper. But if you cut holes, you punch your own holes, and you're dealing with the service side, then I can use a bonding lock nut. I can use a bonding bushing. I can use the bushing with a bonding jumper. I could use a bonding wedge with a metal bonding bushing that ties it all together with a bonding jumper. So I have options here. You only have to seriously worry when you have impairments. And then you just cannot use standard lock nuts. Period. Okay? Makes sense? All right. So that kind of talks about all of our service bonding applications. That's the main part of our service bonding application. So I'm going to take this opportunity to continue on a little bit because we finished a little earlier than normal. So I figure why not talk about intersystem bonding? What is intersystem bonding? Okay, let's talk about this a little bit. Let's see if we can actually come back to our presentation and I will continue on. And we'll go to the presentation and see if we can get into some of this intersystem bonding and look at it a little bit. All right, communication systems. Now, this is 250.94A or B. Now, prior to some changes that took place in a previous code cycle, and I've got my code book here just like you do, hopefully you do. And if you look in your code book, you're going to notice that typically you're going to have some grayed out areas. And you're going to notice that when you look at the code book under this allowance here in 250.94, you're going to see that you have an A and a B. But in the 2017 code, B was grayed out. Not in the 2020 code. What does that mean? Because we added a B option for the 2017 cycle. Okay, so let's explain this a little bit. And I'm going to make sure that I am on the screen because I see that I'm not. Okay, let me explain. Intersystem bonding. If you have CATV, phone systems coming in, cable, satellite dish, whether it's Dish Network, DirecTV, or whatever, if they're coming to a building, all those communication type systems have to have a place to make a connection, and it has to make a connection to your grounding electrode system. And we give you options on where to make this connection outside at the meter enclosure or outside at the service equipment. You can make it directly to a device that connects onto the grounding electrode conductor. We're going to talk about all this. But when it comes to communication, you have a little device, okay? And this little device has to have at least three screws, three settings on it, three screw sets on it, for you to be able to make the connections. Can you have more? Absolutely. But it can only be utilized for the communication systems. This is called the Inter-System Bonding Termination, or the IBT. And again, it's only for connecting, okay, communication systems, and that is it. Now, where can it be? As you see on the screen, for those that are following along, it says the Inter-System Bonding Termination for connecting inter-system bonding conductors is required to be provided externally to enclosures at the service equipment, like I said earlier, or metering equipment enclosures, and at the disconnecting means for any additional buildings or structures. Okay, there is an exception to this rule. If I have a separate building that's not going to have any communication equipment to it, then I don't have to have an IBT. But if there is going to be some type of communication, maybe it's cable TV or maybe it's satellite dish, then it needs to have an IBT connected to it. Okay? Now, a couple other things to remember. You cannot come to this IBT for things like PV connections, for bonding arrays. Okay? You can't do it. Or bonding CST, corrugated stainless steel tubing. You can't do it at these IBTs. Okay? You can't. But we do have an option B, which is going to help you out. Okay? So let's finish looking at option A. What is the deal with this IBT or this block? And we're going to see a picture of one in a second for those that are watching over on the stream. It has to be accessible for connection and inspection. Obviously, it's got to be there for the inspector to look at it. It needs to consist of a set of terminals with the capacity to connect not less than 3 inter-system bonding conductors from 3 different possible types of communication systems. And if you buy them, they're already going to come that way. So don't worry. Okay, it does not interfere with the opening of the enclosure for a service, building, or structure disconnection mean or meter equipment. Now, they make some that clamp on the outside of a meter. They give you the lugs. It just can't inhibit the operation of the meter. Okay, they make other different types that actually will, again, clamp onto the grounding electrode conductor and still give you the number of terminals you need. And they make separate ones that will mount that you can actually add a tap from it over to the grounding electrode conductor in order to be able to meet this requirement. Okay, so it gives you some allowances here. Now, at the service equipment, be securely mounted and electrically connected to the enclosure for the service equipment, to the meter enclosure, or to an exposed non-flexible metal service raceway, or be mounted at one of these enclosures and be connected to the enclosure or to the grounding electrode conductor with a minimum of a 6 AWG copper conductor. Okay, so what this is saying is we're going to let you make these connections at service equipment. We're going to let you make them at meter enclosures. We'll even let you make it to the exposed non-flexible metal service raceway, which contains service conductors. Because you remember, we did all that bonding that we were supposed to do in 250.92. So it should be bonded all together, right? Okay, so we're giving you some allowances. Now, if you want to have it separate, that's fine. You can connect it over to the grounding electrode conductor, and all you got to do is make a connection over at the grounding electrode conductor and run a 6-gauge over to the separate device. So you have a lot of options here. Now, when you're at the disconnection means for the building or structure, let's say you're at a separate building or disconnection means, it says, be securely mounted and electrically connected to the metal enclosure or the metallic enclosure of a building or structure's disconnection means, or mounted at the disconnection means and be connected to the metallic enclosure or to the grounding electrode conductor with a minimum 6 AWG copper conductor. Now, you notice in this case here, we don't see the use of the metal raceway because, again, to that separate building, that would be a feeder. So even if it was a metal raceway, we're not going to be able to connect to that, okay? But at that separate structure, we still have to establish a grounding electrode system usually, okay? There is exceptions to that rule for branch circuits supplying a building. But generally, for a separate building and structure, we have options here. We have the disconnect. We might even have, for example, in some cases, we might have a separate building that has its own meter, and then you just treat that whole building like it's its own service, and then you would kick you back into normal rules where you could do it at the meter, the service disconnect, or what have you. But this is one here's talking about going to a separate building, and obviously you're going to be feeding it with a feeder. And if that building is going to have communication systems in it, then you have to also provide that IBT at that structure as well. Okay. Now, again, if it's not there, you're not going to do it. It's just a garage, let's say, and you're not going to have any communication out there, then you don't have to do it. But if you're going to have cable TV out there or something like that, dish network or something, then you got to meet this requirement. And again, all terminals shall be listed for grounding and bonding. So even when you make a connection to, let's say, the grounding electrode conductor, and you run it off to one of those little nifty little boxes, IBT boxes, again, you still have to make sure you're using, let's say, maybe a split bolt connector that is actually listed for grounding and bonding. Okay, should go without saying, but we want to make sure. Now, this is what it looks like. One of them looks like from one of the manufacturers. This is Irico, and you'll notice here that it is actually connected to directly to a 6-gauge, probably connected right to the grounding electrode conductor, or it has a jumper over to it. Okay, maybe it's the one that's coming out and poking down, and then it's going out, going down to the grounding electrodes. Well, this just gets in the way, if you will. Okay, and everything else would connect to it. So this is an example of intersystem bonding IBT connection. And again, it can only be used, I want to stress it enough, only used for communication systems. Now, you're saying, well, what about my CSST? What about my PV? I want to have a convenient place to make that connection to the system. Okay, well, the code's got you. Not a problem. So what the code says is we're going to give you another option. Now, this is the exception right here that says if you don't have at those existing buildings and you don't have any intersystem communication systems, then you don't have to do it. Okay. Now, the other means. What does that mean? Okay, well, let me get rid of me so those that are watching the stream can see it better. I'm allowed to also option to use a bus bar. It could be copper or aluminum, believe it or not. Some people think they like, really? It can be aluminum? Absolutely. And it's a bus bar that is 1/4 of an inch thick and 2 inches wide, and it is long enough. We don't give you a rule for the length because it has to be long enough, what? To give us our minimum 3 connections, but also it needs to give us any additional connections that we might need because we can use this other means to make other connections, okay? We could use this to connect our CSST. We could use this to connect the bond to a PV system or whatnot to the array. Then we can use the other means. We just cannot use the IBT for communication only because they're only listed for that. But here I could use this bus that I use all the time in data rooms to connect all of the bonding jumpers and everything together, loop everything together. You could use this. It's perfectly acceptable to do that, okay? So the bus bar shall be fastened and shall be securely fastened and shall be installed in an accessible location. Connection shall be made by listed connectors. Again, whether you're drill and tap, whether or not you're putting a hole and you're actually screwing with nut and bolt, a lug on it, it has to be in accordance with 250.8 type of terminations, okay? So just keep in mind that if it's an aluminum bus bar, you have to worry about its connections because it can't be within 18 inches of the earth if it's outside, okay? And it's exposed, okay? Now, we did have some changes in 2020 to this, but yeah, we're talking about a bus bar outside. You're still going to have the limitation not to be within 18 inches of the earth, okay? All right. Now, exceptions to A and B means for connecting intersystem bonding connectors are not required, again, where communication systems are not likely to be used. Well, I'm going to argue that in all buildings that are commercial buildings, all buildings residential, they're all going to have some type of communication system and it has to be there. Accessory buildings or garages that don't have communication systems in it aren't going to require you to put this IBT or option B if you want more options there for other things that need to bond to the system. Okay, not required. That's what the exception is all about. Okay. So bonding of other enclosures, we're probably getting down to the end, so I'm not going to go into this. We're going to save this because it was all about services tonight. But hopefully you got something out of this episode, okay? And are able to understand the significance of bonding on the service. Now, if you're over in our live stream, we're going to hang out and I'm going to answer some code questions that people might be posting, because I noticed that we have some folks posting some questions, so they can be assured I'm going to answer their questions. For you over in the podcast, I encourage you to jump on over to our video stream, because that's where you get to see some of the questions that get posted and we get to answer some of the things. But just remember, bonding is critical. Now, bonding on the load side, I guess I'll answer one question that people ask me all the time. Can I use just a standard lock nut on the load side? Yes. But there are some rules that you have to be aware of. So in the few minutes that I have, let's go look at the code so that I can show you down here when it talks about bonding for over 250 volts. Okay, so 250.97, it says for circuits of over 250 volts to ground, and again, this would be 277, 480, they would be over 250 volts to ground. It says the electrical continuity of metal raceways and cables with metal sheathing, MC cable, for example, would be an example, that contain any conductor other than service conductors. So again, this is not about services, shall be insured by one or more of the methods specified for services in 250.92b. So I can use all of those methods, and I have to, if I'm dealing with something that is bonding for over 250 volts. Treat it like a service. The only one that I can't use was B1. In other words, since it's a feeder, or even branch circuits, I cannot use the neutral. That's what B1 was about for services. I can do that for service bonding, but I can't do that for load side bonding for feeders and branch circuit applications. Okay? I can't do it. So I can do any of the methods in 250.92b. I'm okay with any of those methods we just talked about, other than B1. I mean, I can't use the neutral. But I have some allowances here, some exceptions. It says, exception, where oversized, concentric, or eccentric knockouts are not encountered, or where a box enclosure with concentric or eccentric knockouts is listed to provide a reliable bonding connection, the following methods shall be permitted. What does that mean? What does that mean? What that means is if I've got a box and I know this box is rated for over 250 volts, then I can do what? I can use any of the means here, 1, 2, 3, and 4, in order to bond it. And you'll see those here. I'll talk about those in a second. I got a few minutes. But if I'm dealing with oversized concentric, eccentric knockouts, I've got a problem. I've got to follow 250.92b like I just said. How? What if I'm not dealing with oversized or eccentric or concentrics? It means I knock the plug all the way out. Then I can use 1, 2, 3, or 4. And remember, we're not talking services now. We're talking feeders. We're talking about branch circuits. We're talking bonding for over 250 volts, okay? Now, for 12240, 12208, not a problem. Standard lock nut works fine. Just make sure the fittings are listed, everything's listed. That's not a problem. So you kind of see that the reason I wanted to talk about bonding over 250 volts is because it's very much like services, okay? All right, so let's kind of look at it real quick. Number 1 says threadless couplings and connectors for cables with a metal sheathing. So I can use threadless couplings and connectors for cables with metal sheathing, as long as they're what? Not dealing with oversized, concentric, or eccentric. Okay, so as long as I'm not dealing with reducing washers, I'm not dealing with concentric, eccentric applications, then I can use threadless couplings and connectors with the cable assemblies like an MC cables and all that. No problem. Not a problem. Or if the box is listed for it, the knockouts are listed for 250 volts, then I can still use threadless couplings and connectors. Not a problem. Number 2, 2 lock nuts. So I got rigid metal conduit comes to the box, or intermediate conduit. I can have one on the inside and one on the outside of the box and cabinet. These are standard lock nuts, but I got to have one on the inside and one on the outside. Okay? I have 2 lock nuts. So 2 lock nuts, one rigid or intermediate. One on the inside, one on the outside, sandwiches it down, lock it in, then you're okay. Again, as long as the box knockouts are rated for over 250 volts, or you don't encounter concentric or eccentrics or oversized knockouts, okay? Number 3, fittings with shoulders that seat firmly against the outside of the box. It says fittings with shoulders that seat firmly against the box or cabinet, such as electrical metallic tubing connectors, flexible metal conduit connectors, and cable connectors with one lock nut on the inside of the box or cabinet. That's just a standard application. Again, remember the charging statement here. To be able to do this, no oversized, concentric, or even eccentric knockouts, okay? Or the box is rated. The knockouts are rated for over 250 volts. Then I'm okay. I use standard fittings for EMT, FMC, all those type of things, perfectly fine. And then the last one is listed fittings. I can use any listed fittings with a specific type of wiring method as long as it's listed for use with that type of wiring method. Not a problem for this application. As long as I meet, again, the rules here in the charging statement. Oh, right here in the exception, excuse me. Right here in the exception. As long as I meet those and I'm not in, and I haven't, as long as my box is rated for over 250 volts or I don't have any oversized or concentric or eccentric knockouts, then I'm good to go. I can use the listed fittings that's listed for the wiring method that I'm choosing. Pretty simple stuff when you think about it. All right, that's going to take us back to me. And hopefully you got something out of tonight's episode. If there was any questions that I generated, there's a lot of stuff to cover in an hour. Join me each week during the week when we do exam prep, usually on Wednesday nights at 7 p.m. We just dig into all. Bring your questions. We'll try to answer them. We'll look at some code examples. Join us every Saturday night here on Electrician Live. If there's a topic you want me to cover in future episodes, holla, email me. Let me know. info@masterthenec.com. Also, bookmark next week. We have a great show with Siemens. Special guests. There's going to be 4 special guests on that show. That's going to be, I'm going to have to work a lot of things to do that. So if you're over on the video stream, hang in there. We're going to continue on. If you're over on the podcast, thank y'all for coming. I appreciate you. Until next time, stay safe and God bless. You've been listening to Electrician Live with your host, Paul Abernathy. All right, everybody. Sorry about that. Now we're back at the live stream. So let me kind of look over at some of these questions. I will answer questions germane to this topic where possible. Let's see here. Sam says, I apologize. Sam says he had a heavy drinking episode last night. Okay, I'm sorry about that, Sam. It says, I had a heavy drinking episode last night, but could you explain why a main panel can have no service ground and why the panel can have GN connected but not at a sub panel? All right, so Sam, the reason that you have a main panel and you connect everything together at the main panel, so all your equipment grounds come back to the bus bar, it connects to the grounded conductor, it connects to the grounding electrode conductor, which goes to the electrode, everything is together. That is the start of your system. That is on the supply side of your disconnect, okay? And it's in the enclosure. If any of the metal parts come energized, it's going to do a couple things. One, it's going to allow that current to get back to the source, which is going to be back to the transformer effectively. Remember, there is no overcurrent device that we control on the supply side. So we can't control whether a breaker trips or not. The code says you can do it because it's all at the same potential. It's all going back to the same source. Again, you're providing a low impedance, effective fault current or ground fault current path back to the source. So while fault current travels on all available paths, not just on the path of least resistance, it does travel proportionally on that path of least resistance. So the majority of the current during a ground fault condition will travel on that path with the lower resistance, okay? Or in this case, AC systems impedance. So that is hoping that we rely on the utility to clear something. And we're going to just have to cross our fingers that they do. The code says we have to do it. Now, we can more easily explain why we do this downstream of the service panel, why we do this in the remote distribution panel. Many people call that a sub panel, okay? And that's fine, whatever floats your boat, okay? I get it, because a sub panel goes in a sub, which is like a boat. Anyway, so look, the thing is, the reason we separate them downstream is because you always have current traveling on a neutral conductor. It's always going to handle the imbalance. Nothing is going to be perfectly balanced. If downstream you don't separate the grounded neutral conductor and an equipment grounding conductor, and they're connected together, you're going to have what's called circulating currents. It creates something that we call objectionable current. And it's going to be traveling on all metal parts on its path to complete its circuit. So if we have fault current that's traveling on an equipment grounding conductor, then it's going to travel on all paths, right? Not just the path of least resistance, all paths. That's why we bond everything. But what we don't want to do is intentionally send current through the metal parts because it's connected to the neutral downstream, because we know there's always some level of current that will be traveling on the neutral conductor. So if we were to connect those together, we're going to be imposing currents, and it's going to be circulating currents onto the metal parts. Creates a touch hazard. You come in contact with it, you getting in the middle of that path, you're going to raise the chance of you getting electrocuted. Okay? So, again, we want to keep them separate downstream for a reason. And that is to isolate all metal parts from the grounded neutral conductor, which is going to carry current. So that's why you have to separate everything downstream. Okay? Also, because we have overcurrent devices that we can clear quickly. Okay? And so we want to make sure that we clear it quickly. All right? Also important to remember, in a fault condition, we want everything to go through the equipment grounding conductor path in order to clear the overcurrent device. Okay? We don't want it to necessarily all go back through the neutral so that it doesn't act like it even sees it. Okay? So then there's dynamics involved. I encourage you to get our grounding and bonding course that we have. It's an amazing interactive course. It's been updated for 2020. A lot of graphics. It really hammers all of this home. It really does. So hopefully that explains it to you. Sam, I guess, Sam, you're continuing on that thought. So hopefully I explained it to you because you have a couple here. Again, hopefully I answered that for you. Sup, Nick? Or Ronbo, thanks for coming. Ron's got his code book. Well, you need to come Wednesday night. Wednesday night, exam prep. Not tonight. Electrician Live. Okay, let's see here. Sam, you got really typing away there. So hopefully I answered your question there. I'm not sure. Most of the meters that are designed because of how the meter goes in it actually makes the connection because of how you make the connection in the center part of the meter, and the neutral makes connection, and that lug is usually already connected to the enclosure. Now, not the same for a tenant, like a tenant meter. We're talking about a typical standard residential meter. Now, on big CT cabinets, things like that, then you might have to either add a lug. You might have to do something additional for bonding if you're going to do some supply side bonding in that application, especially utilizing the neutral under 250-142, which permits you to do that. Let's see here. Sam, I'm not sure I can gather all of your pieces because they're really all split up. So I don't know if I'm answering your question or not, but they're kind of all broken up. Let's see here. How is it bonded at the main panel? Is it through the neutral? Now in the main panel, you've got your neutral coming in, right? And you've got that hits a bus, and then you've got what's called a main bonding jumper. That main bonding jumper, if it's a screw, it goes through the bus into the panel in a pre-threaded opening in the panel. That takes the grounding conductor, connects it to the bus, connects it to the metal enclosure. All equipment grounds that come to it will connect to the bus, and then your grounding electrode conductor connects to the bus. That's the way to do it. Now, there's other ways to do it where you have a separate equipment ground bus, but then you have to connect the two buses, the neutral bus and the equipment grounding bus together. And then that jumper that connects in together is also considered the main bonding jumper, because usually you have a ground screw, which you don't size, by the way, and then you have that jumper that's connecting to two bus bars. But that's only, for example, if you want to take the grounding electrode conductor to that separate equipment grounding bus bar. Then you have to connect the two together like that and do everything. But most people just go to one panel lug, one set of lugs in a main panel, have a main bonding jumper, whether it's like a Z-bar or it's a green screw or whatnot. That connects the bus to the main panel, which also connects it to the grounded neutral conductor that's bought to the service, and then you're done. Once you go downstream, that's when you got to use 4 conductors, like for dryers and ranges and remote distribution panels. You got to have 4 conductors then. Or I guess you could use a metal raceway, EMT, rigid, IMC, and that uses as equipment ground. Then you would only put 3 conductors inside the raceway because you're using the actual raceway as the 4th conductor. Of course, I work for a company that makes wire and cables, so I prefer you to put a equipment grounding conductor in there. But again, the code allows you. Code allows you to do it in 250-118. I cannot pronounce that name, but I will read it. It says, Paul, what is the major reason for an IBT? It being non-current carrying and it making a path for lightning? Is that the major safety concern? Well, in a sense, yes, because the IBT is a common location for me to take all of the requirements that are, for example, up in Chapter 8, maybe the array, different types of things that you might have for communication systems that have the requirements for grounding electrodes, all to come back to one common location. So again, the primary purpose of the IBT, interconnecting, rebonding, is one, to not just for lightning, but to also bond all the systems together. One of the big things that happens during lightning is when lightning strikes a system, if it doesn't have a direct path to get to the earth, then what happens? It starts to do horizontal arcing. And it can jump from one spot to another spot that's conductive. Now, what do you think the negative thing about that is? If it jumps across it, and there's something that's in the middle that is combustible, guess what happens? It can cause a fire. So by tying everything together, taking everything at the same potential, again, lightning, things like that, wants to take the best available path. Again, just like anything, it takes all paths relevant to the level of resistance of the path, but it's going to take all paths in order to get to where it needs to go. Okay? So tying everything together ensures that we're sending it in the right direction and where it needs to go. Okay? It also does something else. It keeps it from coming into the system. It keeps it on the outside. It keeps it away from sensitive electronic equipment that could actually cause a lot more damage, cause things like receivers to burn up and blow up if you got cable TV or cable systems or antenna systems. So it tries to keep all of this outside of the structure. Okay, so that's kind of another thing that it does. Hopefully that answered that question for you. Let's see. The next one is, what's up, Ed? Thanks for coming. It says, Paul, was the tester you were talking about made by Ames? Yes, it was. I don't have it with me, but it's a specific one. It's a 1,000-volt rated one. It's got the ticker built into it. Go watch my video. I did a review of it, and I talk about it in there. So I actually don't do product reviews very often, but I did do one for that meter. Again, I know people are going to say it's a Harbor Freight, but it's a good meter. I have put it right next to my popular F brand meter, and it just keeps pace for pace. And it's a true RMS too. Now I use a true RMS and one that's not when I'm looking for harmonics in buildings. Some people ask me to come out, and I'm an old school. I can detect harmonics in neutrals and things like that using an RMS meter and a non-RMS. and depending on how you take the measurements, okay? Kind of old school. I'm not going to do an episode on that. I can hear somebody now say, teach us how to do that. No, somebody would sue me. They'd go out and they'd get hurt. But I learned it back in the day when I was back in my mentor, who I told you was in the Virginia Hall of Fame. And he taught me a bunch of little tips with meters and things like that. So it's something I use when somebody wants to use a high dangle system. Is that such a word? High dangle. I utilize this, and I can pretty much get with some formulas. I can get pretty close and tell them what their harmonics are in their building or where their problem is with what piece of equipment it is. Old school. I go old school on it. Not that I wouldn't like to have that $15,000 equipment. If anybody wants to send me one, I'll do a review on it, but I can't send it back. I got to keep it. Okay. Let's see here. It says, but if you test the continuity between neutral to ground, we read continuity at the sub panel. I don't get it. Well, the reason that you might get it is, well, one thing is you're reading it because you have probably other things all connected together, right? You have things connected together. But if I were to take a panel, okay, now you say you get the reading. Okay, look, if I have a panel and I run a 4-conductor, okay, I run it downstream to a remote distribution panel, okay? In that panel, I just don't put any breakers in it. I put nothing in it. And all I have is a equipment ground bus, a neutral bus, you with me? Separate, and then my hot's coming in, okay? Now remember, back at the main panel, they're connected back together at the same point, all together at the same point. Remember? They're going to the same bus, right? So on a measurement, that's okay because that's the path going that way. They're not traveling on the same, they're isolated inside the panel, but they converge to the same path, or they converge to the same location back at the panel. Remember, it's not so much about what you're taking to the remote panel. It's everything that's going to be connected to that remote panel that we want to keep isolated. We have to start this chain, right? We have to start this, and that's what we have to start. So if you think of it like this, it starts at the panel, separates out, goes to your remote distribution panel. Here, they're on separate lugs. Now, everything downstream connects to it, and that's where your isolation begins. Okay? You with me? All right. Again, it's all about the return path. It's all about making sure that we don't have neutral current traveling back. Now, if you were to go into that remote distribution panel and you were to take the neutral bar and you were to inadvertently stick the main bonding jumper in it and connect the neutral bus to the metal enclosure, which has a separate equipment grounding bus, then everything that you connect downstream from it, you're going to have currents coming in on the neutral. Some of it is going to shoot over and go through the equipment ground. Remember what I said? It takes all paths. Now, obviously, the path on the neutral back is going to be the lower impedance path. However, if something is inhibiting that path, is it not going to run and make a path on the equipment ground? Absolutely. Does that show you that current's going to take all available paths? And what you could have is current traveling on the equipment ground and conductor that you don't want traveling on it. Okay? So hopefully that explains that to it. Again, where it converges, where it's, remember, the back at the panel, they are connected together. So that's just like a parallel conductors, except for on one end, they're not connected together. They're separated. But on the other end, they're together. If I were to ring them, absolutely they're going to come out together. Most certainly. But once I get to that remote distribution panel and I go downstream, hopefully the equipment downstream, like your range, your dryer, you better not have the neutral connected to the equipment ground downstream. So you have separate paths for either the fault current to travel on and the neutral to travel on. You see what I'm saying? Two separate paths. That's the whole intent. Forget about the logic, think about the concept. All about the paths. All about how it's going to flow. Texas G says, hey, Paul, can you explain ground rods and how they tie back to the panel? Actually, that's falls. So you have ground rods, and the ground rods, whether they're 8-foot ground rods, and they're driven in the earth, and they typically are supposed to be driven below the frost line. I don't know what our frost line is in Texas, but most of the time people drive them down to the earth's surface or a little bit sticking up. It's technically a violation, but people let it go. But you connect those to the panel. They connect to the ground and neutral terminal bus panel inside of the main service. Now, we're required to have at least 2 ground. If you're going to use ground rods, just say you're going to use ground rods. If you're going to use ground rods, you have to have 2, unless you can show that one of them meets the 25 ohms or less. Then you can take one away. But if you don't have the ability to show that with a ground resistance meter or a clamp-on ground resistance meter, if you don't have one, then you're going to have to put 2 in. And they need to be 6 feet apart, 8 feet driven in the earth. And then the code says it's a ground rod. Code says it doesn't matter if it's a 1,000 amp service. If you're allowed to have ground rods under 250.66a, then you only need to run a 6-gauge copper or 4-gauge aluminum. Remember, though, 4-gauge aluminum can't be terminated within 18 inches of the earth, so most of the time you're going to use 6-gauge copper, and it goes all the way back to your service equipment, and it terminates on the ground and neutral terminal bus. And that's how you do it. And that's what you would do for ground rods. We're going to cover ground rods, ground rings, concrete and case electrodes. I encourage you folks to think about attending my webinar that I'm having on June 20th. Yes, it's not free. I think it's $69.95, but I can promise you in those 3 hours, you're going to come away knowing everything you want to know about the grounding electrode system and every type of electrode and how they interact. We're going to cover all of that stuff during my webinar. So go over to our website, which is masterthenec.com, and you'll see over there where I have at the bottom where it talks about the webinar we'll be having June 20th. And it's going to be a great 3-hour webinar. And once you sign up for that, you'll get the notice a couple days before the webinar with the exclusive private link that sends you to where you can watch the webinar. And you can ask questions during the webinar. So it's going to be a good webinar and a lot of good graphics. I'm using my grounding and bonding program to explain it. And then I'll go into some other details as well. 3 hours. We're going to talk about it for 3 freaking hours, people. You're going to learn everything you want to know about the grounding electrode system. Everything you care to know. We're going to go over each one of them systematically. Talk about all the nuances. Okay? And it is definitely on the 2020 code. Good news is, there's not enough significant changes. And people know me. When I come to a change, I'm going to tell you what it changed anyway, because I can't help it. I just can't help it. So, again, we ordered it on 2020, but we are going to, if I run into some significant change, I'll tell you about it as well. But there isn't any. There really not going to be any. So, hopefully I answered your questions. Any additional questions that you might have, let me know. For now or forever hold your peace. Hopefully, Sam, I answered your question. If I did not answer your question, I apologize. You had quite a few of them in there, and I was hoping that I catch them all. If there's anything that I stated tonight that anybody got confused, please just let me know. I'm more than happy to explain in more and more detail. Believe it or not, it gets harder and harder to come up with topics because I've been doing this now since 2004. I have been doing episodes every week that I've been in Texas, sometimes multiple. So I really struggle for things that I want to give to you folks. So again, I encourage you to email me with topics, different things you want to talk about. Okay. Next week's show is going to be, it's a bit stressful because I've got a lot of people and y'all all know that I've got a bunch of new software, got a bunch of stuff going on, bunch of cameras here in my studio. I'm hoping just hope it all goes okay. It'll be wild. I'm going to have Vince Delacroce. He's going to be with me. He's going to be scrunched in here right beside me, right here with me. So again, because I had a little bit of a problem, I have another mic, but it's not working, and they could not get me another mic. And I'm a bit partial. This is a Rode mic. I only like Rode's products for mics. So my mixing box is a Rodecaster Pro. Well, they couldn't get me one. So we're going to have to squish in here, but we're going to make it happen. We're going to make it happen. It's going to be fun. It's going to be fun. Let's see here. Question here. Romero, Javier, thanks for coming. Sandra, I see you in here. Joseph, I see you in here. If I missed anybody, real quick, let me do a rundown. I cannot pronounce this name. Our guest Philitin. I'm sorry. I can't pronounce it, but thank you. Thanks for coming. Sam, thanks for coming. Ronbo, thanks. Tim, Code Strong, thanks for coming. Let's see, anybody's Elwood, obviously, thank you for coming as well. So thanks, everybody. Those that are in there who forever hold your peace, thank you for coming. All right, so let me see if I can answer another question here. My eyes are failing me tonight. Paul, how far away does the grounding rod have to be from the main panel, service, or subpanel? Okay, so you're not going to have a ground rod, without getting any confusion, you typically don't have ground rods at your remote distribution panel when it comes to one that would be inside of a building. Now, if I have a remote distribution panel that I'm running to a separate structure, and then I have to establish a grounding electrode system at that structure, the code doesn't tell us whether you're at the dwelling or at the separate structure, how close it has to be. Traditionally, we're going to put it right next to the building. But the code doesn't tell us the length, although it does say we need to keep it as short as practicable. Why? Because we want that current that's coming from things like lightning and transients and things like that gets imposed on it to earth as quickly as possible. Remember, we're not trying to clear a breaker with this. This is on the supply side. We're trying to take, maybe you had a high power line come in contact with your low power line, and we need to shunt it to the earth because, again, the utility has ground rods on every so many feet on their poles, and they can use the earth. We can't use the earth as a return path. They can use the earth. Why? Because they're using small fuses, and they're dealing with high voltages, high levels of current, right? They will trip their little fuses. It ain't going to trip our stuff, okay? You can use Ohm's law to figure that out. 25 ohms at 120 volts, do Ohm's law, and you'll see that that's 4.8 amps. Is that ever going to trip a breaker? I ain't going to never trip a breaker. Stick that lead right in the ground, it ain't never going to trip the breaker, okay? So, and the earth has too much resistance to use. But when it comes to utility people, they can use it. Do you some Ohm's law with that. Instead of do 25 ohms, but instead, how about you doing 13.8? Do 13,800 with 25 ohms and see how many amps you get. Now you'll get the picture. You can trip their fuses. So that's why we're hoping that they have fuses, and they do, on the primary side. That's why we also bond everything on the service supply side so that we can hopefully ensure that we can clear something upstream, that we have some kind of carryover from the secondary transformer to the primary that can cause a primary fuse to blow. That's what we're hoping for. And that's all we can do is hope, because it's supply side bonding. The code tells us to do it. But we don't know. We don't control the overcurrent devices on that. Okay? So, anyway. So, how far they can be, there is no rule except for the further you go, the more subject to damage of the grounding electroconductor you put yourself in, which could ultimately leave you without a grounding electrode system. So again, practical wise, I keep it as close to the structure as possible. Texas says, quick question. I'm attending a trade school in California and hold an electrician trainee card. How will that transfer to Texas after graduation and moving to Texas? I couldn't tell you. You'd have to check. I mean, there's a website we have that we talk about, and it talks about the rules. But basically, you just want to go to tdlr.org, and TDLR, they'll be able to tell you all of the rules. Again, I'm not associated with the states, so I don't know. I know I came from Virginia, and I helped write the exam for Texas, and they would not let me have a reciprocity license. I had to take the license. I was like, fine, let me take it. Then they said, no, you can't take it because you helped write it. So I had to resign from being one of the experts to the state for a year. And then I had to special petition the state in order to let me take the license. They gave me special permission, and then I went and took the test, and I got my license, obviously. So again, I wasn't treated like anybody else. So there's some states that they have reciprocity with, some they don't. I think the key with you in Texas is you're going to have to show your documented hours. Once you show those hours, and I can't remember what those hours are, give me a second, I will tell you. Rather than take our time and look it up on the screen, I will look it up here real quick. I will look it up on my phone and give you the answer to that as far as your hours. Okay, for master electricians, are you talking about a master or journeyman's? Let me look. I don't know whether you want to be a master or journeyman. All right, we'll do is trade school, so I assume you don't have a license. So journeyman. Journeyman, you have to have 8,000 hours of on-the-job experience and pass an examination, okay? So you have to have over 8,000 hours of on-the-job experience, and it has to be documented, okay? And you have to pass the examination. Anything more than that, you need to check with TDLR, okay? Now, the website you can go to that'll give you all the links, I'll read this to you, so listen up. You ready? It is www.electricianschool.edu.org. electricianschool.edu.org. Okay? So all one word, electricianschool.edu.org. Then click Texas. You'll have all the links you'll need to find out what you need. Okay? And that ought to help you. Let's see here. What's up, Nick? Thanks for coming. It says, if a remote panel is installed not in a detached building, you only need the one intersystem bonding termination at the main or both. Okay, so if I have a remote building and I have the panelets in it, I have to have the IBT at that building, but only if I'm going to have communication systems in that building. If I'm not going to have any communication systems in that building, then I don't need an IBT at that building. If I have it at the main structure, my main dwelling, and I have communications, and you probably are, you're probably going to have premise-powered or network-powered broadband. You're probably going to have cable TV. You're probably going to have phone network. Maybe you have Dish Network or Direct TV or whatever. Those are communication systems. Those would be what qualify under this rule. Then you're going to have the IBT. But if your detached structure does not have a communication system, then it's not required. Also, if you have an attached garage to your building, no, you don't have to have a separate one at that remote panel board. You only had to have one at the building. And remember, the garage is just part of the dwelling. You had one at the service for the dwelling. You already had it. So it requires it to be at the service or the meter system for the dwelling. If it's an attached garage, you just have a remote distribution panel in it, no, you wouldn't require it there. Wouldn't be a need. But if you were to leave the building and go to a separate building altogether, if that building's probably going to have a grounding electrode system if you have a panel in it, and you're going to run 4 conductors to it so you can have that separation there, right? We just talked about it. But you're going to have a grounding electrode system there if you're going to have communication systems there. Maybe it's your man cave, and you're going to have Dish Network there. Then you're going to have an IBT there. Okay? You get it? That's how it kicks in. But you got those exceptions that say, hey, if you got no communication systems, then what's the point of having an IBT? It's pointless. You with me? Just remember that IBT can't be used for things like bonding CSST. It can't be used for bonding anything other than communication systems. If you want to bond other things together at that same location and the communication systems all at the same time, then go with option B when we talked about it, okay? If you go with option B, then you put that 1/4 inch by 2 inch bus, then you can take anything you want to the thing. Perfectly fine. Hopefully that answered that question for everybody. I always appreciate you folks coming in and being with me and spending the time with me. Hopefully you learned something. Again, I tell people all the time, I ain't the greatest educator in the world, but I do like to give back and try to train people. I try to give what I can to help you learn. I want you to succeed. I really do. I get the biggest thrill out of hearing when students or people that I know, and I know you interact with me, even those that out there that stay silent, that come on and don't actually type anything. I appreciate you all. And I want to see you succeed. I want to see you go to a job site and have somebody who thinks they're holier than thou. And then you walk in there and you know the difference. You know the code. But you're not arrogant. You're not going to jump and say you're wrong. You're just going to sit back and go, he's not right. He's not right. And I'm going to do it right. I live for those type of things. I make mistakes every day. I am not perfect. There's only one perfect human being. And hell, we ended up killing him anyway. So, again, there's no way I got a shot at it. So at the end of the day, I appreciate you all. Thank y'all. I don't see any more questions coming in. Hopefully you visit our websites, share it, get into any of those programs we have. We had that bundle. That's an amazing deal, the bundle we have. I can't believe I'm giving away all those programs, but that's an amazing bundle. Check them out. I don't have any other questions, so I'm going to bug out. I appreciate all of you. Till next time, stay safe. God bless. You've been listening to Electrician Live with your host, Paul Abernathy.